end the line, and then we'll exit. Just to see what it returns. And I'll put some gibberish for arguments. It doesn't matter here, but I want to see what it returns. All right, so it returns the it'll return the executable itself. It's the executable's name, or the command used to execute the program. All right, let's get rid of that. Wait, I'm sorry. I just realized one more thing. I want to print out one more thing. argv of 0, and I want to see what argc gives me. And this is a quick test, guys, and then I'll be done. And I'll just rerun the exact same thing. So it should, based off of what I understand, it should give off 1, 2, 3, 4. So argc should be equal to 4. Let's see. Yeah, alright. Alright, let's go ahead and get rid of that. Let's go ahead and run it. I really should make like a function on my computer that like will recompile and just run, automatically recompile and run the program for me. Because I'm always like forgetting at times to recompile before running a program after I've made like changes or something to the program. All right. So I'm not going to worry too much about the first two arguments. I'm on the wrong tab. The first two arguments I'm just going to simply set to 0. I'm not too concerned with that. However, I'm concerned with the last 3 arguments. So now we need to come up with some values, guys. And so I think I said I wanted to try out a supermassive black hole for the first example, its mass, and man, a supermassive black hole I think is like on the order of like hundreds. Is it like hundreds of thousands to millions of solar masses? Oh, I have to look at that. Let's actually. I'm going to ask the chat to help me out here. I gotta ask the chat here. So is that correct? For any of you guys who are familiar with black holes, I think it's somewhere like at the lowest it's like 100. It's on the order of hundreds of thousands of solar masses. Is that right? So yeah, let's just go with 1 million suns. That's right. So if I'm remembering correctly from last time, 2 times 10 to the 30 kilograms is 1 solar mass. So all right. So 2e30 is 1 solar mass, but I want to now increase this by a factor of 10 to the 6. So 2e30. This. Is that so? This should make the correction. So that's going to be the mass of our black hole. And so now we're going to need, what's the other information we need here? We need the mass. We need the mass of the object. So we're going to assume. So what's the mass of a human in units of kilograms? I'm going to be honest. I don't know. I think in terms of pounds. And even that's a unit of force. So what would be in and I guess I can go online and do a quick conversion, but you guys can definitely like tell me stuff here. Well, I'm gonna go online and I'm gonna assume like the average person is like 200 pounds. So let's do pounds to kilograms. So a 200-pound person is 91-ish kilograms. Cool. Okay, so then we're gonna use 70 kilograms then. So, Michael, I hate to say it, but we're about to like squash you down into We're gonna make you into a noodle. You're gonna be our test subject here. All right, so or at least a person of your weight's gonna be our test subject. So let's go back to this. You said 70 kilograms. Perfect. And then lastly, I think the last thing we need is the average length. And I'm going to assume 6 feet, but it has to be in units of meters. I do not want to do the conversion in my head because I know inches to centimeters and stuff like that, but I don't think in terms of meters. I think in terms of feet and inches. Let's see. Let's go online. Here. So I want to do, what is that? Feet to meters. There we go. And so if we assume a 6-foot person, that's almost like 2 meters. We're going to round it. All right. So here, 2 meters. And so if I run this, and we are going to ignore. So we're really going to look at the last 3 lines there, or last 4 lines if you're including the prompt. Given a black hole mass of 2 times 10 to the 36 kilograms, an object mass of 70 kilograms, an object length of 2 meters, we get a tidal force of 1 Newton. Which is an acceleration of 0.02 meters per second. Whoa. Does that make sense here? I've never done this calculation before, so because I'm thinking about this in terms of the fact that here on Earth, our bodies experience an acceleration of 9.8. So 10, essentially, meters per second squared. So that acceleration in itself, 10, 100, 1, 2, 3, is 1,000 times greater? Is that right? I want to try something. Let's do a solar mass object. So I can rerun it with the same parameters, but now we're going to go back to 2 times 10 to the 30. Whoa, that's insane. That's insane. Really? So if I'm reading this correctly, if you are if we take Michael, assuming Michael is 2 meters tall almost, 2 meters tall, we take Michael and we put him in the vicinity of a solar mass black hole. The amount of force, because the force and acceleration they're factored the same way. The amount of force, like compared to here on Earth, it's about 1 billion times more. Oh God, that person's getting ripped apart. The amount of force in their body is like 1 billion times more than it is here on Earth. Let's see what you guys got to say in chat about that. Yes, this is Jetlander. Yes, this is the difference in force between the head and the foot, or the head and the feet. Yes. Exactly right. I'm thinking the same thing here. I do not want to be around. At least I don't want to be around. It sounds like if you're around a really like supermassive black hole, you're going to be okay, right? Based off of our calculation before, I mean it's a factor of what? It's 1,000 times less the differential force between the head of a person to their feet when they're at the event horizon of a supermassive black hole, assuming that a supermassive black hole has a mass of roughly a million solar masses, it looks like the differential force is extremely small. But if you're around a solar one solar mass black hole, oh, you're done for. That's it. Oh, that's crazy. Well, guys, it's now 1:02 p.m. now, and this was actually a very fun calculation to do. So yeah, the difference is about 10 to the 12, right? The difference between the two black holes is about 10 to the 12. That's insane. And of course, this is all due to the fact that the differential, the tidal force goes as 1 over m squared. So that actually makes sense, right? Because the only thing that we really changed in this problem was the fact that the masses are off by, what was that, a factor of 10 to the 6. So yeah, that makes sense. But yeah, guys, I had a lot of fun doing this calculation. And there was someone, I think Uncle Bill Drew, and I believe that you suggested this problem. So guys, if you guys have more problems you want to explore, just put them up on the Weekly Space Hangout Crew Slack, and that is if you have access. If you don't, I would advise you guys to go check them out. It's a great group. So yeah, guys, had a lot of fun, and I will be back not next week, but this upcoming Friday at 12 p.m. Central Time, guys. So if you guys have any ideas, send them my way. All right. Later, guys.